Okay, so here is the common language that we use to describe power. 2 to the fifth power is 2 to the fifth power, right? But we can also say things 3 to the second power, we call it squared. So whenever you hear the word squared, let's say 4 squared, it just means 4 to the second power. 16 squared is just 16 to the second power. And why is it called squared? Well, that's precisely because when we relate to geometry, if I have a square that has side 3 and side 3, right? Let's say this is 3 inches and this is 3 inches. Then we ask, what's the area? Oh, well, we know the area of a square is when you multiply these two things up. So it's 9 inches square, and that's why we call it square inches, right? Because it's literally when you do that, you have power of 2 inches times inches. So it's inches squared, right? And then 3 squared is 9. So that's where it comes from. And where does the cube come from? Well, same idea. If you have a cube, by definition, a cube have the length with height being the same thing. So I get 10, 10, 10, right? And you multiply all of them to get the volume, which is 1,000 uh, cubic inches, let's say. So that's that, right? So this is how it relates to geometry and why we name these terms. So again, third power, we can call it cube. Second power, we can call it square. But if you go beyond the third power, if you have fourth power, fifth power, we usually don't have a specific name for them. We just say, oh, 3 to the fourth power, 5 to the sixth power, whatever. Yeah. Okay, cool. So um, we kind of did this yesterday a little bit as well. So we're going to retry these two. Let's say I have 72. I want to break it down to powers, right? So I can get maybe 236, 218, 9, and then 3, 3, right? So if I just do the unbranched ones, I get 2 times 2 times 2 times 3 times 3, so which is equivalent to 2 cubed times 3 squared, right? If we have, let's say, breaking down 135, well, what can I do? Ends with a 5, so let me try 5 then. 5, and then that's 2. That'll be 10, 35, I guess 7. Oh, great. I know how to break this. That's 3 and 9, and 3 and 3, right? So if I put them in the order, 3 is the smallest. So I can 3 to the third power, because there's 3 of them, multiplied by 5, right? That will be 135. And let's see if we have um, 300. Okay, let's see if we can rewrite that one in terms of powers of numbers. Okay, let's give it a try. right. Did we all get an answer? Hayden, what did you get?
I got 5 squared times 2 squared times 3.
Good job. Did everybody get the same thing? This is correct, by the way. Good job. Yeah. So your order might be a little bit different. So for example, if you put 2 squared first, plus 3, and put 5 squared, I would say this is a better way of organizing because generally the standard format is we want to go from smaller number to bigger number. So putting it that way is more standard. But your answer is absolutely correct. Good job. All right, cool. So that's that. Let's move on then. So why do we care about powers? Well, because in powers, that adds a little bit more to our order of operations. So let's say I have a particular thing, like 5 times 8 plus 15 times 10, right? So how do we do this? Maybe I do 40 first, plus 15 times 10, and then I do 55 times 10 and get a 550. Is that correct? Stephen, did I do it right? Not sure, huh? Ruth, did I do it right?
I think, yeah.
Okay. Well, don't copy this down because this is wrong. I am not supposed to do that. Why? Because there is such a thing called order of operation. And you might have heard this phrase before called PEMDAS, right? What does PEMDAS stands for? PEMDAS stands for parentheses. Did I spell that wrong? I think I might have spelled parentheses wrong. And then exponent, and then multiplication and division, and then finally addition, subtraction. So this tells you the 4 steps of like what things we need to do. And I have to do them in that particular order. Okay. So when somebody write this term for me, it indicates that the right way to do it is actually to check, is there any parentheses in this? Well, no, not really. So I don't have to worry about step 1. Is there any exponent in this? Not really. So I don't have to worry about that. But there is multiplication and division, right? These multiplication and divisions take precedence. They are the priority compared to addition. So where are my multiplications and divisions? These two. So what you're supposed to do is do these first. So the right way to do this is to say, oh, 5 times 8 is 40. And then 15 times 10 is 150. And then you add them up to get 190 because the last one is addition and subtraction, right? So notice that this is a different number than what I got because I think earlier I got like 550 or something, right? So that's not the same number. So it depends on the order you do things, you'll get different answers. And this is a like convention. People decided that this is how we're going to organize our mathematical language. So the operation that I did earlier is actually more like this. If I put a parentheses on this, then I go, oh, okay, if I have parentheses, then I'm going to first look at what's happening in the parentheses and ignore everything outside, right? So if I do it in the parentheses, okay, then no exponents, I have a multiplication first. So 40 and then plus 15 in the parentheses times 10, and that will be 55 times 10 to be equal to 550, right? So therefore, because I didn't have a parentheses, that's not the same operation. We gotta do this first before I do the addition. So that's a bit of tricky, but nonetheless, let me pasting a more complete picture of this. Okay, so this is basically the same thing I said. Right, now let's do two more examples. Let's say I have 4 plus 3 times 5. Do I have any parentheses? No, not really. Do I have any exponents? No, I don't. Do I have any multiplication? Yes, so I do that first, right? Ignore the 4, so just copy it down, but don't do anything to it, but calculate this first. So I get 15. And then I get 19 as my final answer. Okay. So if you do this first, you get 7 times 5 equals to 35. That's wrong. Okay, don't do that. We gotta do the multiplication first. Okay. Another example, let's say I have 10 minus 2 plus 8. Well, how do I do that? Is there any parentheses? No. Exponents? No. Multiplication? Division? No. So it's just addition and subtraction, right? Then in that case, we always go from left to right. Yeah, we'll always go from left to right when there's no specific things. So 10 minus 2 is 8, and then 8 plus 8 is 16. Right? I don't have to worry about anything. Okay. Let's do one more before. Let's do another example before I give you guys exercises. So let's say I have this equation over here and change the color, just make it more colorful. 20 divided by 4 plus 17 times 9 minus 6. Okay, oh, that looks a little bit complicated, but we can still go through this process. Do I have parentheses? Yes, I do, right? So this is my first step. Copy everything down. Don't do them. Just copy them down and then work out the parentheses first. So in the parentheses, that's 9 minus 6, which is 3. Okay, so that part is done. I've dealt with the parentheses. Next, I'm going to deal with exponents. Do I have any exponents? No, so don't worry about that. Now, do I have any multiplication or division? I do. So I need to worry about these two, right? These are multiplication division. So do them and don't do the addition. So I'm going to do 5 plus that multiplied together is 51. And finally, I only have addition and the subtraction left. I get 56 at the end. Right? So that's the correct order of doing this. All right, the next one, I'm going to ask you guys to help me out. Let's say I have 3 times 6 squared plus 4. Take a look at this. And Stephen, maybe you tell me what's the first operation I need to do.
Exponent.
Exponent, good. So what does that give me?
36.
Good. 6 squared is 6 times 6, which is 36. Okay. Hayden, what do I do next? Oh, you're muted. Yeah.
Do 3 times 36.
Good job. 3 times 36. In this case, I will get 108. And then Bruce, the last step.
108 plus 4 equals to 112. 112.
All right, so that's that. All right, cool. So that's how you do them. Now, let me give you guys some exercises and let's see how we do. Okay? Okay, let's give this problem a try. Okay, I think some of you have finished. Okay, let's start going over them. Hayden, what did you get for number 1?
I got 7.
Good job. We do from left to right, so 12 minus 5 equal to 7. Good. Stephen, what did you get for number 2?
2.
Sorry, can I hear you?
2.
2. I don't think this is 2. So we do 10 minus 3, that's 7, plus 9, we'll get 16. Okay. All right, number 3, Ruth.
I got 47.
Okay, good. So this one we do the parentheses first, so we're going to get 31, and then do the multiplication, and then the subtraction. So multiplication will give me 62 minus 15, which will give me 47. Okay, okay, good. Next one, Hayden.
For number 4, I got 5.
5. Okay. I think it's not quite 5. So tell me what's the first one you did?
I did 7 plus 2, which is
Good.
9.
Yeah, so it becomes 18 divided by 9 times 2. Oh, you're right, it is 5, sorry. So 18 divided by 9 is 2.
2.
Good. And then we do 2 times 2 plus 1, which we get 4.
5.
Yeah, plus 1 equals to 5. Yep, good job. All right, Ruth, what did you get for number 5?
16 with a remainder of 1.
That is incorrect. You shouldn't have any remainders because the first thing we want to do is parentheses, no parentheses. The second thing we want to do is exponents. Well, there's an exponent here, right? So that's the first one we do. And that will give me 25 because 5 squared is 5 times 5, that's 25. And then we're going to do plus a divided by 2, right? And then what do we do? Any parentheses or exponents? No? So we're going to do multiplication and division, right? Do I see that? Yeah, there's a division here. So we're going to do that first. So it's going to be 25 plus 4, and hence that's 29. Okay. All right, please make corrections if you got that one wrong. All right, number 19, Stephen. 0? Okay, not quite right. So you guys help me out, okay? So Stephen, what's the first one you did? Like, what's the first operation you want to do? Exponent, good. So the 3 squared gives me 9, right? And then what's the next thing you do? We want to do the parentheses, right? So at first, again, PEMDAS, at first I need to do the parentheses. So I know I need to deal with this guy first, but inside the parentheses, I need to do the exponent. So therefore, exponent first. So I got that. And then now I still need to do parentheses first. So it's 19 minus 9 plus 4, which is 13, and then plus 6, right? And then that's going to be 19 minus 13 is 6, plus 6, I get the final answer 12. Right? Does that make sense? Okay. All right, cool. So that's that. Okay, next, I would like to do a little bit with power of tens. Let's see here. What happens if you have 2 times 10? 2 times 10 squared, 2 times 10 cubed, 2 times 10 to the fourth power. What would that give me? Well, what's 2 times 10? That's just 20, right? What's 2 times 10 squared? Well, we can think of this as 2 times 10, the one we did, and then times another 10, right? So that's 20 times 10, so that's 200. So in other words, I'm just adding another 0. And 2 times 10 to the third, it's on top of that, adding another multiplied by 10, so that's 2,000. And if I have 2 times 10 to the fourth power, what do we get? We get 2, 0, 0, 0, 0, 4 zeros, right? So what pattern do you see? The power in the exponent, if I multiply by 10 to the certain power, and the first one will be 10 to the power 1, it just tells me how many zeros I'm going to add at the end of the number, right? So what if I give you a number that's 512 times 10 to the fifth power? How would you write that out? 5, 1, 2, and then 1, 2, 3, 4, 5 zeros. And then if I want to put commas, I can put commas every 3 digits from the right-hand side, right? So 51,200,000 will be the result of that, right? Is that okay? Yeah. But what if I want to divide? What if I have a number that's 397,000,000? I want to divide by 10 to the square. What would happen? Bruce, any ideas?
Take out 2 zeros.
Yeah, exactly. So if I'm multiplying by the 10 to a certain power, it's adding however many zeros I have. Then if I divide by 10 to that number of power, it's just crossing out how many zeros we have. So therefore, this will be 39700. Okay, are we all right with that? Okay, so now we're gonna make things slightly more challenging. What if I got decimals? What if I have numbers that's not very nice looking? So let's see here. What if I have 3.14? I want to multiply it by 10 to the fifth power. Okay, sorry, this like 16 almost. What would happen? Well, let's think about what's actually going on. So this is 3.14 times 10 times 10 times 10 times 10 times 10, right? So what happens when I do 3.14 times 10? Well, I'm making it 10 times as big, right? So a 3 becomes a 30. A 0.1 or 1/10 becomes just 1. And the 400th becomes 4/10. I'm literally moving everybody up by 1 digit, right? And then if I multiply by another 10, I'm making them 10 times bigger again. So I get 314. So at this point, I already used up 2/10. I need to use 3 more. So I get 3 more zeros. So 3.14 times 10 to the fifth power, I added 3 zeros at the end. Well, then you may ask the question, okay, what's going on here, Chris? I thought you said that however many powers is however many zeros that I'm going to add, right? But why is that not the case here? Shouldn't I have 5 zeros? Well, because I have decimals to begin with. The first 2 zeros are essentially canceling out the 2 decimals I have, and then the 3 more zeros I add at the end. So another way to think about 10 to the power is to think about how many decimal places you are going to shift. Every power of 10 being multiplied shifts its decimal to the right by 1 digit. So if I have 3.14, I want to shift it 5 times. This is 1 time, 2 time, 3 time, but if I move it over here, I better add a 0 here, right? And then 4 time, add another 0, 5 time, add another 0. So the decimal is down here. So it's 314,000 decimal, right? But of course, we don't need to write that decimal there, but that's how we get that. Yeah. Okay, now what do we do if I, instead of doing that, let's say I divide by 10 to the third power. What would happen? Stephen?
The decimal would get
Decimal what?
the decimal would get moved to the left.
Good.
Beautiful.
Yes, we'll move the decimal to the left because we're dividing, right? So we're making numbers smaller. So we're going to move it 3 times to the left. 1 time, 2 time, 3 times. So what would that be? So the decimal is down here, but I can't have like dangling place values. So let me put a 0 here. Let me put a 0 here. And this one, you should probably put a 0 here as well. I know sometimes people ignore the 0 at the beginning before the decimal, but I think it's good habit just to include a 0 there as well. So that will be the result when I moved it 3 times to the left. Okay, we're making it of 1,000 times smaller. So that's that. All right, cool. So hopefully we're clear on that. Okay, let's go ahead and work out some practices then. Let's see here. All right, let's try these out, see what we get. All right, let's see what we get. Hayden, can you tell me what you get for the first one?
I got I just moved the
Hmm.
I did 51,000.0.
000.0. I think that's a little bit too many zeros. So let's try that together. Okay. So we have 5.1, right? So how many times should I move it?
3.
3. So let's move it once over here. So now the decimal is over here, right? So that's the first time I move it. And now it's 51. Now I move it again. Second time I move it, now it's 510, right? And then move it one more time, put it here. So that's another zero into that. But that's already moving it 3 times already. So that's out, 5,100. Okay. All right. Uh, Ruth, what did you get for the second one?
I got 42.600. I mean, 42.60.
6. You don't need a zero, okay? Don't put the zero at the end. It's unnecessary to put zeros after like the decimal. Okay. Right, just do that. Again, same idea. We just gonna move it once, right? So just move it there. No need to add zeros at the end. Okay. All right. Steven, what did you get for the third one?
0.576.
0 point what?
576.
Yeah, 0.576. That is correct because we started having the decimal over here and we're gonna move it 1, 2, 3. So the decimal should be right here. So if I just move the decimal over here, it should look like that, right? And oftentimes we put a zero in front to make it look nice. Okay. All right, cool. Number 4. Anyone want to try? Okay, I'll just review the answer. For this one, 1.25, we're going to move it 5 times, right? So 1, 2, 3. So adding 0 now. 4, 5. Move it 5 times. So now the decimal is right here. The original decimal is gone. So the number should look like that. Okay. All right, cool. Okay, we're gonna take a 5-minute short break, come back at 2:20, and then we'll continue from there. Okay. Okay, so next we are going to do a few more questions, but I will guide you guys through, and these may be slightly changed from what we're doing, but it's the same concept. We're still multiplying or dividing by powers of 10. So let's take a look at these problems. Let me put them in here. Okay. There we go. So in this one, they say 1,000 or 10 to the power 3 multiplied by something will give me 68, right? Well, how do I do this problem? How do I figure out what that number is? Well, I can see that I have the number 68 over here. So this probably has to do with something like 68 or 680 or 6.8 or something like that, right? So therefore, what can I try? Well, why don't I just start from 68 and see what happens? Now, if I have 68 and multiplied by 1,000, so I'm adding 3 zeros at the end, right? So if I add 3 zeros, yeah, I got that number back. So this one is just going to be 68, right? Does that make sense? Good. All right, so for this one then, we have 280, but this number over here has 2 more zeros. So what do you think we need to have here? Yeah, Ruth?
100.
100, good. So I need that extra 2 zeros to make it happen, right? So therefore, if I multiply 100 by 280, I'll get 1, 2, 3, 3 zeros. That's what we need here. Okay. All right, same idea. All right, Hayden, do you want to try number 3? What do you think the number I need for number 3 will be?
Probably 76.
76, almost, because we also need a 1 there. So we can have 76 and add a 1, 761. Then when we multiply by 1,000, we add that 3 zeros. Notice that the numbers that we multiply, we don't actually have the 1. right? We don't add the 1 here. There's no 1 here. Because the 1 is basically this is 10 times 10 times 10, right? So each time I multiply by 10, I don't need to add the 1, I just add a 0. Same idea here. If I'm multiplying by these numbers, I'm adding 3 zeros at the end, so I need a number that's before that, so 761. Okay, all right. Bruce, what should I have for number 4?
786.
786. Good. Since I have 2 zeros here, we have 2 zeros here. I just need the thing in front of it. Yeah. Okay, good. Let's see, number 5. Um, Stephen?
132.
132. Good. Same thing. I have 10, just 1 0. So I have 1 0 here. That's good enough. Okay. Number 6. Hayden, you want to give this one a try?
Mm, probably 6,000 or 61, 618,000
How many? Just tell me how many zeros I should put.
or 2 zeros.
2 zeros. Good. So,
So
mm,
61,800.
good. That is correct. Sometimes I get lost, like is it 1,000? Is it 10,000? Yeah. So usually I just write out the number 618, and then oh, how many zeros? 0 0, and I go oh, that's 100,000. So let's put a comma here. Oh yeah, comma there. So it's 61,800. Yeah. Good job. Okay. Good. All right. So now let's give this problem a try. Okay. See how all right, Bruce, you done? Okay, good. Stephen, Hayden, are you guys done? Not yet. Okay. Take your time. All right, shall we go ahead and get started and going over them? All right, let's see number 7. Hayden, what did you get?
For number 7, I got 1,000.
That is correct. Good job. Number 8. Ruth, what did you get?
857.
Good. Number 9, Stephen?
399.
Yep, 399. Good job. And number 10, Hayden? You're still muted. I cannot hear you.
2,790.
Good job. That is correct. Good. Number 11, Ruth?
1,000.
Mm-hmm. Number 12, Stephen?
100.
100. Good. Number 13, Hayden? Oh, you're still muted.
215,000.
Good job. That is correct. And Ruth, number 14?
229.
Mm-hmm. Okay. And number 15, Stephen?
410.
Good job, 410. Notice that this one we actually need a 0 here because they only gave me 3 zeros. So make sure you also include 1 0 for the other number. Okay, good. All right, and the last number will just be 85,000. Nothing crazy there. Okay, good. So hopefully we're gonna handle this. Now I'm going to make things slightly more complicated by multiplying a number that's not necessarily 10 or 100 or 1,000, but the idea is the same. So let's take a look at some examples. First one, pretty straightforward. If you have 1 times 7, that's 7. If you have 10 times 7, we add a 0. 100 times 7, we add 2 zeros. However many zeros I have in the number I'm multiplying, how many zeros I'm going to add at the end, right? But what if I have 2 times 8, right? 2 times 8 is equal to what?
16.
16, right? So, and then what if I do 20 times 8? What if I do 200 times 8? What if I do 2,000 times 8? Well, just like the pattern we see on the left, it's still going to give you the same number, right? But then I have an extra 0 here, so I'm just going to add a 0. So I'm going to need to color code them as stated. So maybe I say, oh, what if I have a 0 here, a 0, 0 here, and 0, 0, 0 here? So since I had 1 0 here, otherwise it's just 2 times 8, I'm just going to add a 0, right? And the next one, same idea. This is going to be 6, color coded. Let me just rewrite that. Okay, let's say all of them will start from 16, and I'm just going to add however many zeros that I'm given. So put 2 zeros here, 3 zeros here, right? Okay, cool. Now, is that true then? However many zeros I have here will be however many zeros on the right-hand side. Well, it turns out that that's not always true, even though it's a good rule. Did I kick somebody? Sorry about that. Okay, and so let's see here. What if I have a number that's, let me use black, 4 times 5, right? So 4 times 5 give me 20. But what if I want to do 40 times 5, right? Now, that one will give me 20 still, because 4 times 5 give me 20, but I need to add that extra 0 as well, right? So here I'm going to get 0 and put a 0. What happened to that 0? Wait a minute. That's weird. Okay, why is it doing that? Okay, let me rewrite that. So if I have 4, yeah, and green. If I have 40 here times 5, that should actually is 200 because I'm adding that 1 0 at the end. But notice that I only have 1 0 here, but I have 2 0 here. That could happen if the original multiplication without any zeros already give me one of those things, then yeah, I'm going to have some extra zeros. But the zeros that we have in the factors, right, that will determine how many of the zeros I'm going to add at the end. Okay, so similarly, if I have 4 times 5, let me just write it out a little bit more. 4 times 5 is equal to, say, 20, 20. So let's say if I have 2 zeros here, I'm gonna add 2 zeros here. If I have 3 zeros here, 3 zeros here as well. Right, so that's that. Okay then, what if we go a little bit more crazy and allow both numbers to be multiples of 10, right? So let's see this one. If I have 10 times 7, what would happen? Well, you can think of this as 1 times 7. That gives you the 7 over here, and then just count how many zeros I need to add at the end. So I had 2 extra zeros from both guys, so I'm going to add 2 zeros together at the end. Okay, and then the second one, same thing. 100 times 70. Well, this is essentially 1 times 7, and then a bunch of zeros, right? And then 3 zeros, 4 zeros together, and 4 zeros at the end. Okay, all right. Now, let's do something that's a little bit more complicated as an example. Let's say I have 2,100 multiplied by, say I wanted to do 12 and then 0, right? I want to do that. Okay, so what you can do then is to say, oh, I'm going to multiply the things without a 0 and then just count how many zeros at the end. So you can do 21 times 12 to get 42, 21 with 0 here. So I get 252, right? So that's equal to 252, but I'm not done. I still need to count the zeros. There's 3 of them, so put 3 zeros at the end, and that will be the right answer. Okay, and to do that, oftentimes people just do this. What I was taught is that you can just line them up. You can say, oh, I have this number, and then I'm just going to line up the non-zero part. I'm going to put 12 here and put a 0 here. And then go, oh, 2 times 21 is 42. Put a 0 here. 1 times 21 is that. And then this is going to be 252. And I just look at this, like how many zeros are there, right? And put them down here like that. So this is one way, a modified way of doing the vertical multiplication when you have zeros at the end of a bunch of numbers. Okay, so that's what you can do. Ultimately, it's the same idea. If you have zeros, you can kind of ignore them for a little bit and then add them back later. Okay, so that's what we were doing. So let's start with some very simple questions and see how we do. Then I'm gonna give you a little bit harder ones. Okay, let's try this out. This should be very, very simple. Right, I think it's kind of pointless for me to wait for you guys to finish, or we'll just do them all together because this is simple now. Okay, Hayden, can you give me the answer for number one? The three numbers for number one?
60, 600, and 6,000.
Yep, 6 out. Oops. I can make this slightly smaller and slightly wider. Yeah, that works. 6,000. Good job. Where the dash is. Oh, okay, so that's that. All right, good. And for the second one, Ruth, what do I have?
8,808,000.
Good. All right, the third one, Stephen.
6,616.
Good. All right. Hayden, number 4.
110.
I don't think it's 100. 60 times 5.
60 times 5.
Let's think about 6 times 5 first, right? What's 6 times 5?
6 times 5 is 30.
30, and then we add a 0, right? So what do we get?
300.
300, good. Okay, and the next one?
3,000.
30,000, good. And then the next one will be 30,000, yeah. Okay, good. All right, cool. Okay, maybe I just handwrite. I don't know. Typing actually, I don't know why it's so narrow. Okay, Ruth, what's number 5?
4,404,000.
Good, 4,400, 4,000. Number 6, Stephen.
9,909,000.
Good, 9,909,000. Hayden, number 7.
20 or 210.
Good.
21,000. No.
You can just say how many zeros?
1,100.
Yeah, 2,100. Good.
And 21,000.
Good. All right, Ruth. Number 8.
404,000, 40,000.
Good. All right, next one. Stephen.
404,000, 40,000.
Good. Hayden.
21, 210, 2,100, and 21,000.
Okay, let's see here. 3 times 7 will give me 21, right? How many zeros should I have?
2.
2, yeah. So let's add one more zero here, right? So each one of them, this one would have 3 zeros total, and then this one will have 4 zeros total. So let's add one more zero to it. Okay. All right, Ruth.
1,000, 10,000, 100,000.
Good, because 2 and 5 will give you a 10, and then you still have 2 more zeros to add up, right? So that's that. Good. And then Stephen?
3,600, 36,360.
Yep, good job. Okay, good. So that's that. Now, let's move on to something a little bit more challenging. If I have to multiply 3 numbers together, how do I do that? All right, where's my cursor? Oh, there we go. Okay. Let me do a couple examples for you guys, and then you guys can be okay. All right, so what if I have 10 times 20 times 30, right? Or 3 numbers multiplied together. So what do I do? Well, same idea. I'm going to just look at the numbers that doesn't have the 0, right? Doesn't have the 0 at the end. So it's 1 times 2 times 3. And then I'm going to add 3 more zeros too, right? So I have to think of it as I multiply by 1,000. So 1 times 2 times 3 is going to be 2 times 3, so 6,000, right? And then the next one, same idea. I can go, oh, what's 2 times 4 times 5? That's 8 times 5. So that's 40 And I have 1, 2, 3, 3 more zeros at the end. So 40,000. Yep. And the same thing here. I go, oh, 20 times 30 times 40. So it's 2 times 3 times 4. And now I'm going to go another 3 zeros at the end. So that's 6 times 4, which will be 24. And then put 3 zeros at the end. Okay. So again, you're just counting how many zeros that you have. All right, let's give these problems a try. All right, let's go over them. Let's see here. Hayden, why don't you tell me what did you get for the first one? You can just tell me the number and then tell me how many zeros comes after that.
Mhm. 56, there's a zero, then a comma, then 3 more zeros.
Good. Yeah. So 4 zeros in total, 56 and followed by 4 zeros. Good job. And put a comma in the thousands place. Good. All right, 52. Let's see here. Stephen, what did you get?
6 and 4 0.
How many zeros?
4.
6 and 4 zeros? I think we need 5 zeros, right? Because we have 6 times 5 times 2, that's going to be 30 times 2, which will be 60, right? And the 60 already have 1 0, and then you have 1, 2, 3, 4, 4 more, so total 5 zeros, and then put a comma in. Yeah. All right, okay, cool. All right, number 53. Ruth, what did you get?
150,000, comma, and 3 zeros.
Okay, so 15 followed by 4 zeros. Good. All right, cool. Next one, number 54. This one's a bit harder. Hayden, do you want to try?
I got
If you haven't got to this problem, that's okay. Just let me know.
I did it, but I didn't add enough zeros.
Ah, I see. Okay. So let's do it together then. So we're gonna do 5 times 4 times 5. So that's gonna give me 20, right? And then I'm gonna go 20 times 8. So that's gonna give me 160. So I'm gonna write that down first. 160. And I go, oh, how many zeros are here? 1, 2, 3, 4, 5. So I'm just gonna put 5 zeros after that. And then I look at this, I go, okay, where do I put the comma? Putting comma is always going from right to left, and then every 3 digit you put a comma, right? So 1 comma here, 1, 2, 3, another. So this is like 16 million. Okay. All right, cool. So that's that. Bruce, did you get 55?
Yes, is it 36,000, comma, and 000, 3 zeros after?
So 4 zeros in total?
Wait.
I think there should be
No,
5.
there's supposed to be 1 more zero next to the 6.
Good. One more zero. Yeah. So therefore, you should put a comma here and put a comma here. So 3,600,000. Okay. Again, every 3 digit you put a comma, right? 3 digit, comma, 3 digit, comma. Starting on the right hand. Okay, good. All right, for 56, Stephen,
72 and 5 zeros.
can you say that again? I couldn't hear you.
72 and 5 zeros.
Good. 72 and then 5 zeros. And put a comma here, put a comma here. So 7,200,000 will be the right answer. Okay. All right, good job. Hopefully you guys are getting the hang of this. Again, once you do enough of them, it doesn't seem that difficult, right? At the beginning, it may be a little bit challenging, but once you do enough, it's not too bad. Okay, all right, cool. So for homework today, I will probably send out an email to Hayden, and then the rest of you, I'm gonna print something out for you. Okay, so just a quick review. So today we covered 3 different topics essentially. So we first talked about powers and exponents. We talked about how the little number on the top just indicate how many of them are actually multiplied. So that's a definition that you need to know. And then we talked about order of operation, making sure that now we have exponents, and exponents precede multiplication and addition, right? So follow the correct order when you're doing things. And finally, we dealt with multiplication by tens, hundreds, thousands, and division by extension. But we're going to focus on division a little bit more next time. Okay, so we learned a lot today. That's like 3 distinct topics. So good job, everybody. I'm going to send out the homework, get ready for that, and we can stop here. And Hayden, I think that's it for this week. And next week, I should see you. Let me look at the calendar real quick. I will see you Monday, Tuesday, Wednesday, and Friday. Yeah, and that will be 4:30 next Monday. Yeah, okay. All right, cool. So let's wrap up, and I'll see you guys next time. Bye. Okay, all right, let's go ahead and get started. We're going to discuss this book. So all of you should have been reading, and I do think most of you have turning, or those of you who are in the Google Classroom have turning the what's it called, the pre-reading response. I see that I think Aaron, you submitted twice, but Justine, I didn't see yours. So next time, make sure you fill out the Google form, okay? If you have trouble accessing it or you don't know what to do, let me know. It's just a very simple form to kind of get you thinking as you're reading. Okay. All right. So with that said, we're going to discuss chapter 1. Let me record this actually.